Hi, let's take a look at Chapter 10 and Problem 7. And here we have a problem that is dealing with pooled variance. So the problem states we've got one sample where the SS is 70 and the second sample has an SS of 42. In Part A, if n equals 8 for both samples, find each of the sample variances and calculate the pooled variance. Because the samples are the same size, you should find that the pooled variance is exactly halfway between the two sample variances. Well, let's take a look and see if that's the case. So in Part A, both sample sizes n, so n equals 8 in both cases. And so if we take a look here, we're going to find that the variance for sample 1 is going to look like this. The SS for sample 1 is 70, and the SS for sample 2 equals 42. So we come over here and we take the SS, 70, going to divide that by the degrees of freedom. Okay, sample size is 8, so n minus 1 equals 7. So that is going to be 70 minus 7, and that equals 10. Okay, for the second sample, this is the first sample, so, and in the second sample, that's going to equal SS over the degrees of freedom. Okay, that equals 42 divided by 7 equals 6. Now for the pooled variance, that's going to look something like this. We've got S2, let's call it P, S2P, pooled variance. Okay, so that's going to be S1 plus SS2 divided by DF1 plus DF2. That equals 70 plus 42, and that's 7 plus 7. That equals 112 divided by 14, and that equals 8. And we'll notice that 8 is halfway between 10 and 6, just as we would predict. And now for part B, now assume that n equals 8 for the first sample, so we'll call that n1, and n2 equals 4 for the second. Again, calculate the two sample variances and the pooled variance. You should find that the pooled variance is closer to the variance of the larger sample. So let's write that stuff down before we forget. So for N1, the sample size N1 is going to equal 8. N2 equals 4. That means that our degree of freedom for 1 is going to be 8 minus 1, or 7, just like it was before. And this is going to be 4 minus 1, and then it's going to be 3. Okay, let's move this up just a little bit so we have a little more room. Okay, so we do everything about the same, and of course for sample 1 it's going to look a lot the same. So we've already calculated S21 from before, and that's going to be 10. It was 10 before, it'll still be 10. So let's look at the new S22. Okay, that's going to equal SS2 divided by the DF2, and so that gives us 42 divided by 3, and that's going to equal 14. Now, if we have that pooled variance again, S2, call it P, is going to equal SS1 plus SS2 divided by DF1 plus DF2. That equals 70 plus 42 divided by 7 plus 3. That equals 112 over 10. And that, of course, equals 11.2. And you'll notice that 11.2 is closer to our larger sample size than the smaller one, just like we thought it should.